state of software-defined networking. I did this in, or I should did this in Singapore, but somehow we get out of schedule, wonder, and at the end there was no time to present it. It was good. I had prepared presentation for the E3, which never happens to normally. That's really good. And but you are first ones which will get this presentation. Yeah. Two things about this is I normally say I don't use corporate slides. That's really not true. I will use slides from VMware, from Cisco, and from Microsoft, because I had no. I don't know. I really don't want to make my slides all the time, because it's a lot of work. And second thing is definitely my opinion. Yeah, that means that's not the opinion of company I work for. It's not the opinion of you. You can agree or disagree. I would actually like if you disagree to tell me, maybe, maybe I will learn something out of it. That means it's only my opinion, which we see here. Okay, what I am Sasha Mažić. I work as an infrastructure architect, or actually I work as an IT architect, but what I work is infrastructure, data center infrastructure. I work for that data port, or data port actually, not data port, data port. It's German set. It will speak, we have to say, it's like German. And that's governmental-owned company which do IT services for 5 German states. I'm grandfather of PAP4, I think, or 3, proud of it, really. VMware vExpert, I mean, I feel before. That's an achievement.
Is that the official icon for grandfather, or?
No, for this one, just for here. Yeah, it's for W. For this, look, this is the head.
Yeah, I know.
Actually, I put it extra, when after the event. You can find me in LinkedIn, Twitter. Oh, okay. Twitter, I must say. In the meantime, I have Twitter client on my mobile phone. That means if you tweet me something, I will notice it. I cannot, promise that I will retweet it, because mostly I cannot. I don't know how it works. But at least I will read it, yeah? Which is good. Yeah? Okay. Any question? Okay. What we will do in this half an hour is, we have a few questions. Is why, how? We will see this movement from Nicira to NSX, and we will speak what alternatives Cisco and Microsoft do in this software-defined networking space. And the question I think the most part we will be in why and how. And I come to my most interesting question is why? Why you want to do it? And what is the reason? Okay, question is, in anybody of you, like the VMware guys, has software-defined networking project? Okay, what did it?
I've done VXLAN and NVGRE and Cisco NX 1000s.
Okay, and for what customer? Okay, what was the reason why you do that?
First for an enterprise deployment, for essentially just building out large test environments for isolation, and after that quite a lot of consulting work for companies that want to go hybrid and essentially build their on-premise networks in a bubble, so that when they're connecting with the cloud, that bubble doesn't affect what's on-premise.
Okay, to manage this, like, lot of customers or a lot of tenants?
No, actually for making sure we don't cross boundaries for things like PCI compliance and stuff, so the stuff that's sitting inside the bubble doesn't affect what's sitting outside the bubble, so the compliance stays locked.
Okay, what as NSX or?
Quite a lot of it actually over in the Microsoft world, so it was NVGRE for quite a lot of the implementations.
Okay.
And then Cisco did a lot of the NX 1000K stuff.
Okay, in my perspective, why we have, okay, first thing is why we have to do this is, I will say in some perspective, I cannot tell you 1 year, 2 year, or 5 year, or even maybe 10 years. We will do it Actually, internet service provider, most of them, or has already did it. And that's actually, and they did it because it's better way to do network. And second thing is, it's also better way to organize data center as such. You know, that's not the reason, okay, I will say nobody did it because they can. You know, that's not the reason why to do why we do. You know, there are few stuff which actually drive this. I would say security is one of them. Because when you have software defined networking, it means that all connections between your endpoints in this network are defined. And that's the main reason why you have to do it. That means you define every connection, you know every connection. And if and no other connection could be possible. And that's, I think, for me, the main reason. The second reason is, when you do software defined, you actually know the all connections, which in a lot of network environment you don't know. When you ask the network guy, can I connect to this road? Sometimes, I don't know, there are firewall rules, let me look. That's actually what is for me the most. Second thing is, business agility. You can do it when you have software-defined networking in place. You can do very fast, connect new people, new products, new services, whatever you want. Second, you know, everything is going cloud. You know, the cloud companies. I'm not saying everything is cloud, but you know, these companies like Amazon, like Azure, even like VMware, they are pushing us like data center provider. Because they are benchmark for us. It means if we cannot take the pace of development and cannot take pace of billing with these guys, at one point of time our customer is saying, sorry guys, you know, we can accept that you are 10% or 15% more expensive, but we cannot expect that you are like 3 times as much as the other. That's actually what drives everything. And the second thing is, we have already virtualized everything. Is anybody here which has less than 50% virtualization in the data center? Even we, which I will say we are not like bleeding edge, we are like 98.5%. And I think in the field is the adoption rate of virtualization even higher. And when you have virtual machine, what happens if you don't have software-defined network? It can happen that your data pack go out of your environment, go in some switch. Switch says, oh, go back in the same machine, and also to go to firewall, go back to the same machine, which actually is silly. But it's happened. We had in, what is this? I should not talk so much.
Those are your words. No, it's you saying that you shouldn't talk so much.
No, but they talk too much then.
Sasha, can I have a quick question?
Yeah.
So you talked about the first one with the security.
Yeah.
You said that with software-defined storage, you know all the clients.
That's network. Network.
Defined network.
You know every client that connects. Yeah.
No, every connection between endpoints, you know all of them.
Yeah, but you know that in the switch as well. I mean, how
The thing is, I can only explain NSX. I don't know the other things.
Yeah.
The thing is, we have firewall directly on the virtual network card. Yeah. So we can, on the virtual network card, we say the packet is allowed or not. So it does not go out of that VM. Yeah. So it doesn't go out to the router or to the firewall. It will stop here.
It will never be
Maybe I didn't tell it to you.
Right.
What I mean is, you can do everything firewall. You know, you say this connection is allowed, only this connection is allowed. Which
based on what MAC address or IP address?
You can choose.
You
can choose.
Name it. Yeah. Okay, you can do this with the firewall. Okay, I will say like this. You can do this with firewall rules now as well. But we will not do it because, you know, you will not do it because you have to do it on the firewall. And you have to to tell every firewall in your network that the rule is set, which is hell of the job.
I can show you one slide if you want.
Please don't go for a slide, you know.
Sorry, no, that's not. I can show you one slide which explains it. Yeah.
Go on, Sasha.
Okay, that's what I tried to explain.
Sasha, one thing, the security, what Sasha said. So I'm for VMware, yeah, but let the people, customers, yeah, ask us. And the security point is one really big reason. We call it microsegmentation.
Yes.
Cisco would call it maybe one other.
Okay.
But the security point is really a big game changer.
And it's slightly easier, I would say, to manage than a tiered firewall approach, because you have, like, I don't know, hundreds of firewall rules that you have to maintain instead of one group policy or one
One wrong rule and it's...
Yeah. And the whole thing goes.
But the
and
most
it
problem
takes
is-
weeks to figure out why it didn't work or why it works.
Okay, the most problem is actually to spread the policy among a lot of firewalls, especially when you have geographically spread environment, which we have. Actually, we wrote our own software to spread the firewall rules. And that's actually a huge amount of people which do. We have 10 people only which care that policy is spread around all firewalls. That means it's not easy to do that. It's possible. I think in small environment is of course easier. In bigger environment, not so easy.
And it's less secure. A tiered firewall approach is in my opinion less secure because it takes more effort to maintain it, and then you're not proactively checking is it allowed or not. You create a rule and it's there and you never change it.
Yeah.
Apart from it doesn't work, then you change it. But otherwise, there are ports open, they may be open for a project that is long gone, and they are still open, stuff like that. So that's really the major issue that you have, because you inherit a lot of stuff that is not actually really needed anymore.
Okay, what this actually does, what network virtualization actually means. You know, when you have normal switch, okay, it sounds like, I think it looks a bit like AP switch, but it's not. This is not what I want to say, that only happy switches. You have the data control and management of the network, actually everything on it. And when you manage your network, you also manage switches. And that's actually, when you have a lot of switches, that means you have a lot of, there are tools, there are a lot of tools which help you there, but doesn't matter, your data, moving, control and management are all in switch. What network virtualization does is actually divide this piece. That means the forwarding plane data, okay, switches, they move data, yeah? They will move data in the future as well. Switches, yes. Control is actually done by management, and control, there are protocol which controls the switches. That's actually what network virtualization does. That's actually simple said. Question is, do you want this or not? I will say logically, we will say, everybody will say, yes, we want it. Yeah, it's great. We virtualize compute, we virtualize storage. Why we not virtualize network? Yeah. Okay, who of you think that is a good idea to virtualize the network? Yeah, they will throw you out.
Every time I go and
Okay.
but we can see you are really old because you use a hard disk, floppy drive.
No. I want, that was
So that's a 3D representation of the safe button.
The wanted is also old. But what I want to say to you is actually by my presentation you should hear what I'm saying, you should not look what causes on the...
Well, I have a floppy disk at home if you want one.
No, but actually that's a trick. What should associate this? This association is actually software-defined network.
Yes.
Okay. Do you want software-defined networking or not? Floppy is for software, there are network on it. Okay, when you have to explain a joke, maybe it's not so good. But
Those are the best ones.
I don't know. Okay. The question is. Oh, wait. Okay. I missed one slide. I don't know why.
Stop, you're making us sick.
Sunday morning.
People have been drinking yesterday.
Okay, I come back to the one. Okay, I missed my slide. Maybe I should reload the presentation, but doesn't matter. There one slide more. But okay, question is why we're not doing it now? Cost is one.
It's a Sunday morning.
It takes, so we can say it takes a while at the customer side. So customers are looking at that. At VMware, that's the second largest growing group at VMware, NSX, yeah.
Yeah, but it's not difficult to grow from 700 users to last year.
I don't know.
So, yeah, I mean, it's still new. It's very new.
We are really,
And if you have a large network, you're interested, but exchanging this for, that's a lot of work.
you're really right.
So it's all POCs.
Your biggest challenge is the fact that most enterprises have already got physical infrastructure in place, which
Yes.
is simply not compatible with the software
Exactly.
networking. So I've got a firewall, Net5, and all these devices, which essentially cannot pass through the data plane without
Yep.
learning how.
And also for the network guys, the network guys are quite old-fashioned. Adoption is,
PowerShell.
I'm not doing that. I'm not trusting virtual.
No.
Okay, please, let's speak up.
It's the same with storage, Joe. And
Yeah.
you see the movement now.
I think it's, I by mistake I said software-defined storage, but that's also a technology that's, I mean, it really takes time for.
Because they'll lose their job.
It's also, but what I did beside for me, okay, I can speak for my company, my company is not like measurement for everything in the world, yeah? But what I see in my company and our customers, network, mostly is in company beside the costs, which are really big now, but should not be big in the future. The point is that storage guys and compute guys, in most companies actually pretty tight together. And you can do a lot easy move from virtualization to software-defined storage. Especially because nowadays all storage which you buy is actually software-defined. That's easy move. But networking guys are mostly not connect to anything, even if they do a networking, which is actually, paradox as a
That's
such.
the safest way of networking.
Yeah.
No,
To connect to anything, exactly.
I didn't get to the one.
and they only speak Unix, of course.
Oh, they speak like,
iOS.
I had got to the question, but sorry. When virtualization for computers was starting in the early 2000s, I think one of the reasons for some people was that they got independent on hardware. They could basically buy another server brand and put the software on, and they had this abstraction layer, meaning they could be really flexible. Would that be the same case with the network?
Yes.
So that
Yeah.
you can buy a different kind of.
For example, with NSX, you can have a Fritz box. You know that? Yeah, you can have a Fritz box, yeah. And the only thing you have to have is an MTU of 1600, and it doesn't matter which switch you have.
It should be managed right, and it should
Which
run
is
SMB.
managed from. The great thing was at Cisco live in Berlin. Cisco last year Cisco said fuck off NSX and so on, but that's okay, yeah. We are in competition. But this year, frenemies, yeah. But this year at Cisco Live, they said use NSX for the virtual stuff, for all your virtual machines and so on. Use our stuff for the top of the rack switches, because you have top of the rack switches.
They want to sell their
And
stuff.
they want to sell that stuff.
But you just need the ports. You don't need the configuration on the switch
Okay.
itself.
question?
Sorry.
Do you want, I say no easier. If you really want fast software-defined networking, it's actually pretty easy. Everybody can do it. You don't have to buy anything. Okay, you have almost not to buy anything, and you can do it on your own. It's pretty simple actually. You buy some kind of open hardware switch, which you can specification you can download by Open Compute project. You can buy this at Trend Micro. Was Trend Micro? Super Micro? What is it?
Supermicro, yeah.
Super Micro or Quanta or whatever. Then you have cheap switches. Okay, that's the first step.
But what if you want to run VLAN tagging the switches, then you need some managed switches that can do that.
So VLAN tagging essentially is going to be turned off in all these places. So when you move into the software-defined networking scenario, you've got to understand how the protocol, the control plane and the data plane operate. But effectively, all traffic for all of your virtual machines run under one VLAN. So effectively, you've got a control VLAN going across, whose job is to talk to all of the hosts. So if it's Hyper-V servers, Index 1000Ks, or VMware, essentially it doesn't matter. They're all under one VLAN. So all of the other VLANs you've had sitting in your Word, they sit continuously doing what they were, but all the things that's happening to find are in a separate VLAN completely.
Okay, second stuff which you have to do is you have to connect the switches. And that actually should be very simple, It should be scalable, like top of the racks, nice. Our network guys say that's not so easy to build simple network, yeah? It's more complicated as a thing, but actually simple, scalable network, high bandwidth, and quality of service. Why you need quality of service? Quality of service you need because you want to prioritize some services which you provide to your software-defined networking. Or you could be able to do this. If you don't have quality of service, then you will not be able to prioritize services. That's actually, you don't really need it, but in software-defined networking is also good because you can easily prioritize services. That's the main thing. Then you should implement OpenFlow protocol, which is really open and you can read every specification, what it does. Actually, this is the protocol between forwarding plane, means the router which moves stuff, and control plane. That means where the rules are set. Huh? Then you can put in virtual environment bunch of Open-V switches, and you can use the OpenStack networking stack for control. Problem is, nobody in one enterprise environment will do that. Yeah? If you go to your boss and says, oh, I read all of this, I understand all of this, and I can implement all of this, they will say, are you not? That's not how the enterprises work. That's actually the biggest problem. What enterprises need is key in the hand solution. Yeah. What actually good when you implement all of this, I showed this slide from VMware, but means that switching, routing, load balancing, communication to physical network which is not virtualized, and firewalling, VPN, and even kind of lot of extensions that we have, they will all work over this software-defined network. That will be all defined through software, not through hardware. It means your hardware switches, they're only connected in the kind of way that they how to say, Austauschschutz, redundancy, yeah. They're redundant, they connect easy together, high bandwidth, that's it.
No, they offload as well.
Huh?
They offload their functions as virtual network function now. So if you happen to have a device with an S6, one of the newer Cisco's, for example, or an F5,
Yeah.
then those routing functionalities offload into the software-defined network, so they're still important.
Yeah, okay, when you do the Cisco way of doing stuff.
Or Microsoft.
Or Microsoft. Yeah, okay. But doesn't matter actually. Yeah? But most important thing is the switches can be like connected and managed. The whole functions are really dead in software. Okay. And you do this. And then you're done. You have nice network. Then is Nicira. Nicira is a company grounded by the people which find this. And they do this as a work at the university. They combine all three stuff, put some black magic into it, and had a first enterprise-ready software-defined storage. VMware said networks.
Your fault, man.
That's your fault. Network. You know, it's,
You confused him, you confused him.
yes,
That's what I'll take the blame, sorry.
Yeah.
it's okay, but you, I still, you know, some, oh, we have a blame ball.
Does it say absence?
Yeah.
Yeah, okay, I agree.
I think we have 5 more minutes. Yeah, but I must say it's nice with you because we discuss a bit like more this, how to say, really open discussion as I talk and you listen.
Okay,
Yeah.
sorry.
Okay, they sell this to VMware for 2.4 billion, I think.
No. 1.5 billion was AirWatch, and that was our largest acquisition. I don't know how much we paid for it.
Oh, nobody knows, but I hear that is really big. Actually, a joke about this is that why is NSX so expensive? No, VMware put a huge amount of money for it, then they count how many customers they have, they divide the price per customer, and that's how they came to 6,000 euro.
Is there another way to do that?
No.
5 minutes, thank you.
How are you calculating your prices at Dataport?
Oh, very simple. We look what our costs are and put like
Divide that by customers and charge them the share that they would use.
Yeah.
So it will be cheaper soon then?
Yeah.
I hope they don't make their prices like one large German retailer, yeah. A PC at MediaMarkt costs 360, so that's 10 euros over per month over 3 years.
Yeah.
Yeah, that's okay, we come with all in. Okay, going forward and okay, we do now the very fast one. We have 3 okay, I do this for project, I actually evaluate 3 of that for our company. And I will tell you what was the result of it. But first we will see what NSX is doing. Actually, this is the, how to say, software-defined networking in a like core version, yeah? It's pure software-defined networking. That means your switches are silly as possible and management should be easy as possible. You have a switch, this router and firewall into the kernel of virtual of host. Means these 3 services are in kernel and they are actually very fast. You know, they have a slight overhead. You may slight overhead on this, but it's really good solution, good idea to put these 3 services really into the kernel. Eh?
No, it's not.
That's Cisco, but doesn't matter. I will not say again.
Right now, it's only VMware that's locking it directly into that switch.
Okay.
Yes, taking it out.
I think that's a great idea. I will say also what is great idea Cisco. You know, they have also one really great idea as well. No,
Only one.
this is only one great idea. Look, it's really complex system. You know, I will need like 10 minutes pro vendor to explain everything. Yeah? But you know, then they have some kind of virtual machine which is called NSX, and everything else is there. Yeah? And they are connected to this. All other functions are into it. Then they have control, which controls all of this. NSX Manager, that's the place where you can automatize it with your stuff. That's where the API is shown. And okay, the cloud consumption, I mean, my company we are not here yet, but actually that's where we will start. In the case we will do this. Because like water company, our whole fabric is Cisco, yeah, and all our virtual machines are VMware. And actually the part of the project was to make sure that we do software-defined networking and we not land with both of them. And that's actually, you know, and we have them like double of cost. That's the main reason why we did it. Yeah. And then there are really more, okay, that I showed already. Question to it? You have like 1 minute discussion on something, if somebody...
Yeah, also some Cisco slides.
Yeah, I have one, but 2 Cisco slides. Actually, Cisco slide and the
Move for time.
Cisco slide, because I did actually 1 slide pro vendor.
Yeah, that's fine.
Okay. Okay, Cisco slide. Cisco Application Centric Infrastructure is actually the the idea is that you have control plane and forwarding plane in the switches. What I think is pity that they use only N1000 and 9,000 series.
7,000 as well.
7,000.
7 and 9.
Yes, okay, and part of the 7, as I present, yeah. 9 and 7, which is actually the top of the notch product.
It's based on the SCIS chipsets, which has actually been moved down and changed, but these were the first hardware to have
Yeah,
this in.
and I think that Cisco will do better with it if they also have it in actually all series.
3,005.
Yeah,
Yes, it's going.
Because it's, okay, I can only get information I can get.
Yeah, you are from Cisco. I'm a Cisco champion. Okay, so, yeah.
Okay. That means the difference between NSX and Cisco is actually not so big as you would think. Yeah? The difference is these 3 core functionalities there in Canon. That's actually what Nicira did with this black magic stuff. And the rest is going onto this open vSwitch, which is actually NSX Edge. By Cisco, everything happens on the switch. There's 2 stuff. That means switch is do switching, and this high network functionality goes to management, but control plane is also on the switch. And that's the difference. I must say, what I see as a risk is spreading of information. And you have a huge network. I think the VMware system is because you have everything in data center. Every switch is in data center. But for our case, we have switches all over, like half of Germany. To spread information, that will be not easy. Yeah. It can be a challenge. That's what I see.
You're only going to spread the information to where you have the virtualization required. So if I happen to have an enterprise with 50 locations across the planet, 2 data centers that happen to just host my hypervisors, it's only those 2 data centers that I'm actually going to pass the software-defined plane. I'm not going to send the software-defined plane into the other 48 locations unless I actually have a business reason to, which generally I won't have.
But I will tell you what is actually the great about it. Cisco has something called endpoint root. And that's actually the magic out of it. Because if you have your endpoints in this endpoint group, actually it doesn't matter where you connect it. Yeah? When you define this endpoint group, you can connect it anywhere. If it's something broken in one point, it's easy to go to another point, plug it in, and like magic, they will be connected with the same rules that you defined in the beginning. And that's actually what I think is really good about Cisco software-defined network. This magic for endpoint group. That's really great stuff. That's something which you cannot. Okay, as I said, you can implement everything with everything. You put effort in it, but that's for me like good idea on it. That's actually really smart. That means you define the rules and connections. You can do everything. But have I 2 minutes? 3 minutes? 2 minutes. Okay, then I must move on. I will say the last thing about this Microsoft. Microsoft is not so far yet, I will think.
I'll correct you in a minute. Go on.
Huh?
I'll update. You go first, and I'll give an update on the Western side.
Okay. But the idea of Microsoft is they built actually Linux virtual switch, which they do. That's actually not the complete truth.
No. So there's 2 versions of software-defined networking. Do you mind if I do?
I want to finish.
Yeah, you finish.
Okay. Microsoft is actually, the definition of Microsoft network is actually part of Open Computer Project. That's sorry. Okay.
So Microsoft have 2 versions of software-defined networking. V1, which was brought out in 2012, that's been end-of-life in July of 2017. It's gone.
Yeah.
In 2016, so the technical previews, we are now looking at a V2, which is wrapping around your open flow open vSwitch scenarios, and has also turned around and watched exactly what the VMware teams have done with VXLAN, and essentially made that their primary virtualization protocol. So essentially the NVGRE stuff that we have does exist and will continue to exist, but it is essentially a depreciated protocol. It is not turned on by default in 2016. The reasoning behind that simply is because VMware have had the head start, and as a result of having the head start, then all of the offloaders, so we go back to our Cisco devices and all of the other third parties that are doing offloads, they have already embraced the VXLAN protocol, and as have the Ethernet adapter people, so they can offload and do the software defined on the actual data plane much faster. So Microsoft basically says, well, why invent another protocol? We're not winning the battle, let's focus on other things. So as we move into 2016, we move into this. Now there's one thing I'd like to go back on, is your Cisco word where you're talking about the fact that it's using a separate technology. The key thing I think that's missing across here is that all three players have actually made an agreement in the software-defined networking between Cisco, Microsoft and VMware will actually all interconnect.
Yeah.
So what we're looking at is the concepts that the parties that play behind that in hardware world, so the F5s and the Ciscos of the world, these guys have all now turned around and said, F5, I'm really good at doing load balancing. Cisco, I'm really good at firewalling, IPS and routing. Microsoft and VMware are basically, we're really good at getting stuff out of our virtual machines into data planes and controlling them through control planes. We need help to do the software functions that are load balancing and stuff. VMware have bought a third party to do.
Netscale also supports the VXLAN.
Exactly, and this is the key piece. This is the key piece. All of the players have already turned on VXLAN. There was, I think, 2 players that actually, and F5 and Cisco being both of them, that actually turned on NVGRE. Everybody else just looks at, why bother? So NVGRE is dead. Straight up and honest, it's done. So what we're looking at now at this point is Cisco have come back with, as you said, with the expensive switches, the 7000 and 9000s, and they are damn expensive switches, with a chipset known as ACIS. That allows us to turn on what is known as a virtual network function. So I can actually tell the network device that I'm going to send you a control plane flow that has data coming across that needs to be load balanced. Use your hardware offloads to load balance this thing, and I won't bother doing it in software. So today, if I don't have all of this expensive kit, I can use Microsoft's solution, or I can use VMware's solution, and I can have a virtual load balancer which is completely in software. But these things are useless beyond maybe layer 4, where they can do maybe IP to IP or tuplet to tuplet, but they can't do application levels, so you won't get cookie persistence or stuff. If I move up to the ACIS functionalities, boom, I can go all the way to layer 7 and I can do everything that F5 does, but inside that software-defined plane. And that means then ultimately that if I decide in the morning that I need to actually push out a new network, then I can say I'd like to have 3 subnets, 2 load balancers, an IPS device and everything sitting in my environment. I have no physical work to do other than saying, have I got the approval to turn on part of the compute power inside the F5 or inside the Cisco and have that in my virtual network. And that becomes mine, I configure it, I define it, and the network guys get nothing other than a status report to say that, well, there's another virtual function being built in those devices. So that word is re-amalgamating, but that step happened only 2.5 years ago when Microsoft, Cisco, and VMware all sat around the table to basically say, you know what, lads, we're all fighting the same damn argument, we're all going different ways, none of us are getting any shackleware, let's fix it. And we baselined, and the first big one to see is somebody like Microsoft saying, you know what, we fucked up, we wrote the wrong protocols, we're dumping it and starting again. And you're seeing these players making moves that we'd have never ever seen before, because everybody would turn around and say, oh, actually,
and all of them are working together. For example, we have at NSX, there's also load balancer, but we say if you have F5 big IP, please use that. We are not
it's a new
as
word.
good as that.
Yeah.
And also we are
Actually,
also with Palo Alto, so I think Microsoft will also do that. They are working together with Palo Alto, so offloading of virus scanning and so to Palo Alto is
Yeah, exactly. They're all together.
Okay. The conclusion for us was actually the same as you came. We will wait actually till the main players came into the same main line. Yeah?
but that's not good for us, so we need your money.
Yeah. You think it's not good for you?
Okay, the question
That's right.
No, question is also, you know, when you have the software-defined data set at the end, it's not only a problem of technique, it's also a problem of organization as such. You cannot do this with the same organization you have now. especially when you have network guys which don't talk to anybody, and you have the storage guys which don't talk to much people, and you have compute guys which know what to do is, but only that what they say is good and then everything else is bad. That we need also for software-defined data set a different organization. Actually, that's what we want to start as a company. We will change the organization.
The organization doesn't need to change much. What needs to change is the skill sets. Because
as well.
effectively, you turn around.
That's new people.
Well, maybe it is actually.
Okay, thanks a lot.